Right, so like we said in my previous video, you still remember that if you have got resistors that are arranged in series, the formula that you can apply for finding the total resistor, you simply apply 1 over resistor total, which is equal to 1 over, since we have 3 resistors, so I'll say 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3. So that is what we mean. So this is the formula that you can apply. Now, you can keep on adding that depending on how many resistors you have. There's no problem with that. So this is the formula that we can apply there. Well, let's imagine that resistor 1, let's imagine that from this circuit, my resistor 1 is equal to maybe, let me say 2 ohms. My resistor 2, let's say that it is actually 3 ohms, and my resistor 3, let's say that it is actually 4 ohms. Then they tell us to find the total resistance. How is it going to be? So applying the formula, 1 over resistor total will be equal to 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3. So it will be 1 over the resistor total will be equal to 1 over, what's the value for resistor 1? It's 2 plus 1 over, what's the value for resistor 2, which is a 3, plus 1 over, what's the value for resistor 3? It's actually 4. So we find the common denominator. So it is going to be 1 over resistor total will be equal to, what's the common denominator of 2, 3, and 4, which is simply a 12. So 2 into 12 is 6. 6 times 1 will give me a 6 plus 3 into 12 is a 4. 4 times 1 will give me a 4 plus 4 into 12 is actually 3. 3 times 1 will give you a 3 there. So it will be 1 over resistor total will be equal to this plus that will give me 10 plus that, it will give me 13 over 12. So remember, for us to find resistor total, we want RT, which is the resistor total. We cross multiply. This times that will give me 13. R total will be equal to 12. So to find R total, divide 13. What I do this side, I'll do it the other side. So therefore, I can say my R total will be 12 divided by 13. So what is that going to give us? Using the calculator there, we're going to say 12 divided by 13 to 2 decimal places. It will give me 0.9, 2 ohms. So that is the total or the combined resistance that we are going to have. Well, let's apply some more and try to see how you can go about that. So the question may simply say, as an example, let me say calculate the equivalent. So calculate the equivalent resistance. Calculate the equivalent resistance in each of the following. So calculate the equivalent resistor in each of the following. Let's say A, we do have what we are calling as being, let's say that we do have that in the first one, and let's say that in the second one we do have so let me say that you have got this is a 1 ohms resistor, and let me say that this is a 2 ohms resistor, and in the second one let's say that we have got 3 resistors that are arranged in parallel. Okay, so that becomes easy. So that is a 1 and a 2 that I'm having there. Let me say that maybe in the other one that I'm having there, we can simply say that we have a 6. Let me say that we have a 6, we have a 3, we have 6 ohms there, we have a 2 ohms there, and let me say maybe we have a 3 ohms there. Now, if you remember, maybe I can deal with that. What we did say to find the equivalent resistance. So when the question says equivalent, they will be using words like equivalent is the same as total. So words that they are going to use, they are going to say find the effective resistance. Sometimes they can use words like find the combined resistance, or sometimes they can use total resistance. So we can use equivalent, effective, or combined resistance in the circuit there. Now, of course, we can apply the formula that I showed you to calculate the total resistor because there are only two resistors in what we are calling as being, in parallel. I'll call this one as being R1 and I'll call this one as being R2 for the sake of simplicity when I'm calculating. So for the A part, it will be 1 over resistor total is equal to 1 over resistor 1 plus 1 over resistor 2. So it will be 1 over resistor 1. Sorry, resistor total will be 1 over, what's the value for resistor 1? It's 1 plus 1 over resistor 2 is actually 2. So it will be 1 over resistor total will be equal to, you find the common denominator, which is 2. 1 into 2 is 2. 2 times 1 is a 2 plus 2 into 2 is simply 1. 1 times 1 is a 1. So it will be R total will be equal to this plus that will be 3 divided by 2. Next, you cross multiply. This times that will be 3 times R total is equal to 1 times 2 is a 2. To find R total, I'll divide through. What I do this side, I'll do it the other side. So meaning that R total, 2 divided by 3, the two decimal places will be 0.67, and that is going to be ohms. Now, I want you to notice something, that when you calculate the total resistance for resistors in parallel, the total resistance that you get cannot exceed the lowest resistor. So the lowest is 1, so it's 1 or less than 1 when you combine, as long as they are in parallel. So let's try to look at the B part. If I look at the B part, you are going to find that we cannot actually, when we find the total resistor, we don't expect it to exceed 2. 2 is the lowest resistor for these resistors arranged in parallel. So when you calculate, it can either be 2 or less than 2. Let's find out. So because there are 3 resistors, I'll call this one R1, I'll call this one R2, and I'll call this one R3. So our formula will be 1 over resistor total is equal to 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3. So it will be 1 over R total will be 1 over resistor 1 is a 6 plus 1 over resistor 2 is a 2 and resistor 3 is a 3. So it will be 1 over resistor total will be equal to the common denominator there. We can use 6. 6 into 6 is a 1 times 1 is a 1 plus 2 into 6 is simply a 3. 3 times 1 is a 3 plus 3 into 6, that's 2 times 1, which is a 2. So it will be 1 over R total will be equal to, when we add what is on top, we have a 6 over, 6 there, 6 over 6. Then from there, we can cross multiply. So it will be 6 R total is equal to 1 times 6 will give us a 6. I'll divide 6 to find R total. So it will be R total will be, remember that is 6 divided by 6, which will give us 1 ohms. So that is going to be 1 ohms. So that is the total resistance that we have in there. So you can see the value that we have gotten is actually less than the lowest one that we are going to have. Now a quick one, if there are only 2 resistors, if you only have 2 resistors in parallel, you don't need to waste time if you only have 2 resistors in parallel. So for 2 resistors, you can use what we simply call as being the inventing, so we can simply say inventing rule for 2 resistors in parallel. So you can use the inventing rule for 2 resistors in parallel. So meaning, if you have got only two resistors that are arranged in parallel, you don't even need to start wasting time. No. For example, if this is R1 and that is R2, according to the inventing rule, to find the resistor total, it is simply the sum of, it is simply the product of the product of the 2 resistors, the product of resistors that you have, the 2 resistors that you have, divided by the sum of resistors, the 2 resistors that you have. Remember, this only applies when you only have 2 resistors in parallel. So R total will be equal to, so you just multiply R1 multiplied by R2, then you divide by what we are calling as R1 plus R2. So basically, That is what we do if you only have two resistors in parallel. So you apply this formula here. Let's say that we have this one as being 3 ohms and resistor 2 is simply 6 ohms. Then how do I get that? Well, you're going to say your resistor total will be equal to, so what is my R1? It is 3 multiply my R2, which is a 6 divided by 3 plus 6. So resistor total will be equal to 3 times 6 is 18 divided by as 3 plus 6 is simply a 9. So what will our R total therefore give us? It is going to give us 2. It is actually going to give us 2 ohms. Again, you can see that the combined resistance that we have is less than the lowest there. So that is the way you can do it. Now suppose you are having resistors, a combination of resistors both in parallel and series. What can you do? Well, if you have got a combination, so if you have got maybe let's say combination, so combination of resistors in series and parallel, then what can you do? Well, it's very simple. Let's say that we have got this resistor and that other resistor, then we also have this resistor and we have that other resistor, and this, so you have got resistor 1, resistor 2, let me call that one resistor 3, and let this one be resistor 4. Then they tell you to say find the effective resistance. Then how do you go about that? Let me say this is a 2 ohms, let me say this is a 3 ohms, let me say this is a 6 ohms, and let me say this is a 3 ohms. Well, what you do is that to get the resistor total, it is simply the resistors that are found in series plus those resistors that are in parallel. That's what you do. Now, if you notice, resistor 1 and 2 are simply in series. So resistor total, I'll just say resistor 1 plus resistor 2. If they're in series, you just add, remember, plus. For those resistors in parallel, if we only have 2, we don't need to waste time. So I'm going to say resistor 3 multiplied by resistor 4 divided by resistor 3 plus resistor 4. So that's what we mean. So it's those in series plus those in parallel. Let's use the values there. We see the total resistance that we are going to have. So resistor 1 is a 2 plus. What is resistor 2? It's a 3 plus. What is resistor 3? It is 6 times resistor 4, which is 3 over 6 plus 3. So this is going to give us resistor total 2 plus 3 plus this times that is 18 over 9. That's what we're having there. So resistor total, this plus that, 2 plus 3 plus, remember 18 divided by 9 is simply a 2. So we are now going to just add that one. So therefore resistor total will be 2 plus that, 5 plus that, that is going to give us a 7 ohm. So that's the final answer. So that's basically the way you can actually go about that. Now let me quickly look at a few other examples and how you can go about it. Some other examples that you're going to be finding in the exam that you need to become familiar with. Suppose they tell you to find the effective resistance. For example, if you have maybe, let me say, find the effective resistance, you have got such type of maybe resistors arranged in a circuit. Let's say that you have that and you have that. How is it going to be? Let me say that is a 4 ohms, that's also a 4 ohms, and that is an 8 ohms. B, let's say that again you have got resistors that are arranged in this format. You have got resistors that are arranged in this format. How do you find the total resistance? Let me say that is a 3.0 ohms, that's a 3.0 ohms, that's a 3.0 ohms, and that's a 3.0 ohms. Then the equation says, find the effective. So find the effective resistance. So we want to find the effective resistance for the two circuits there. All right, that's very simple. For the first one there, remember this and that are actually arranged in what we are calling as being in what? in series. So if they're in series, what do? You can simply just add that. So when I add that, it's like I'm going to have a circuit which is going to become something like this. So you do have, it is going to become like this when it is reduced. So this is the 8 ohms resistor that you have there. So when you combine these two, they'll give you this one here, which again is simply going to be 8 ohms. So now you can see that those are simply now two only in parallel. So how do you get the resistor total? Remember what we said, you can simply add, multiply them, the product divided by their sum. So it will be 8 times 8 is 64, divided 8 plus 8, which is 16. If you divide 64 divided by 16, it is simply going to give you 4 ohms. So that's the idea. What about these ones that we have for B? Well, again, you can reduce this circuit. This circuit, these two can be combined, they're in series. So you're going to find that you can combine them, and these are in series, so you just need to 3 plus 3, that is a 6 ohms. These are also in series, you can just add them, that will give you a 6 ohms. So you can see what it has reduced to. So we can now find the resistor total by finding the product 6 times 6 divided by 6 plus 6. So that will give us 6 times 6 is 36 over 6 plus 6 is a 12. When you divide, that will give you 3 ohms. Well, watch out for other questions and see as we do the typical questions that came in the exam based on these circuits that I've looked at. See you in the next discussion.